Just check everything over and make sure that you have the answers correct for this page. What's the page number on this?
6.
Okay, page number 6 is where we left off yesterday. The key idea being understanding how to calculate what this leap is worth right here. That we know we do not have 2 full leaps. So you've got to figure out 1, 2, 3, 4. It's 5 out of 6 or 5/6 of a leap. If this helps also to understand what this value is here, make believe that these are tape diagrams or fraction bars. And since we are leaping in leaps of 6/8, our first leap is complete. We need to get to 11/8. So technically what you're doing is you're shading all of these boxes. Because this box here gets me to 11/8. And so what we've shaded out of the entire 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 is we've shaded 5 out of 6. And that's kind of how we get our 1 5/6. Okay, and if you're still not clear, I'll go over it with you before you start the actual exercises, which I've got to explain to you anyway. All right, so next page. Is this. Was the second side of your homework last night, so if you weren't able to do it, it's okay. Now you have 2 denominators you got to change. That's the key, because you can't do leaping until you have the same denominator. You can't just change one, you got to change both. So if you look at your 4 and you look at your 3, what number can you come up with that 4 goes into and 3 goes into? Preferably the smallest number. It's 12. That's going to actually go here, okay? We're still going to do the how many blank and blank statement. How many 2/3 are in 3/4? And then we realize we've got to change it to a denominator of 12. So now what we have to do is we have to create our equivalent fractions. 3/4 becomes what? Over 12. Taylor. Right. 4 times 3 makes 12, so 3 times 3 is going to make 9/12. We have to do the same thing with our 2/3. 2/3 now becomes what over 12? John, it becomes 8. To see it? 3 times 4 is going to make our 12. Therefore, 2 times 4 is 8. So what we have now, our new equation, or our new expression, is 9/12 divided by 8/12. We have everything we need now to construct our line and our fractions. Count in 12ths. There's 12/12. I'm going to keep the fractions in proper. You're going to see we're going to need all of the number lines. We're going to need all of the lines to do this properly. If we look back at our question, we're trying to figure out how many 8/12 are in 9/12. I know that here is my 9/12. I make a dotted line because that's where I kind of need to get to. And to get there, I've got to leap in values of 8/12. So I've got 1 full leap. We know it's got to be greater than 1. And I'm going to make that second full leap, but I'm going to do it as a dotted line. to show you that I'm going to need a piece of that leap, because 16/12 takes me too far. I need to figure out what this is as a fraction of the whole. So if you take it and just forget about this 1, I'm looking from here to here, and it doesn't matter whether you do a fraction bar or a tape diagram. This piece represents 1 out of how many total pieces from there to 16/12. Ed, it's 1/8. Here's 1, 2, 3, 4, 5, 6, 7, 8. I have 1 and 1/8, and that's my answer. This is kind of why I think the number line works a little bit better. You could kind of see it. If you want to do a fraction bar too, you can. Whatever model works best for you. I just don't want you doing keep, change, flip just yet. You're more than welcome to use keep, change, flip to check your answer. But for right now, I want you to get used to number line or fraction bar to prove your answer.